Hi guys, you're welcome back to this new session of integral. Here we have a fractional integral that we wish to integrate. Okay, so here the best approach to integrate this is to apply the partial fraction method. Okay, so the first of all, what we do is to first factorize the numerator here. Okay, so factorizing the numerator, we realize that the common factor out here, the common factor of this term of the numerator is 1 on 4. It's 1 on 4. Likewise, the same for the denominator. The common factor is also 1 on 4. 1 on 4. So factorizing 1 on 4 out for the numerator, we will get 7. We'll get 7x squared. Okay, then plus 5x, then plus 13. Then for the denominator, we get x cubed plus x squared plus 2x plus 2. And that's from there, our factor will cancel out, leaving this and this as a new terms for both numerator and the denominator. So after that, we factorize the denominator. Okay, so let's put everything into practice. So we will have the integral of 7x squared plus 5x plus 13 all on x cubed plus x squared plus 2x plus 2 dx, as we've explained from the intro. So here we now factorize the denominator. Okay, so factorizing the denominator, we I've already explained this in my previous video, so you can go back to the previous video. So you go to click on the link as shown in the description for you if you want to know how to factorize this. Okay, so we have the integral of 7x squared plus 5x plus 13 all on, so we have x plus 1 x squared plus 2, okay, dx. So what I'll do is I'll use the partial fraction to solve this integral here. Okay, so we'll have the integral of 7x squared plus 5x plus 13 on x plus 1, okay, x squared plus 2 will be equals to, so we introduce the partial fraction variable, so we have the integral of e on x plus 1, okay, plus, sorry, dx first, dx, okay, so plus the integral of, since the factor here, it's not possible to factorize it, so we introduce a linear expression. So bx plus c, that will be our linear expression for it, x squared plus 2, okay, on x squared plus 2 dx. So we factorize this, okay, and so we find the value of a, b, and c. So once again, click on the link in the description for you to know how we got the values of a, okay, and b and c, all the constants. So we got their value to be, for a is 5 when you solve it by partial fraction, okay. You get a to be 5, b to be 2, and c to be 3. Okay, so that means that we'll have the integral of 5 on x plus 1 dx plus the integral of 2x plus 3 on x squared plus 2 dx. So this means that we have, this will be equals to, so factorizing this, integrating this, we have 5 lane absolute value of x plus 1, okay. Then okay, so let's write it separately. Let's write them separately, okay. So we have we have the integral of 5 on x plus 1 dx will be equals to 5 ln absolute value of x plus 1. So take note of this, okay, plus c. So we also integrate the second one, this, okay. So we integrate the second term, so that will be the integral of 2x plus 3 on x squared plus 2 dx. So we can break it down, okay, to be separated terms of the numerator. So we have the integral of 2x on x squared plus 2 dx plus the integral of 3 on x squared plus 2 dx, okay. So with the first one, with the first integral here, we can apply the U substitution. And with the second one, we apply the trig substitution. So applying the U substitution for the first one, we have U equals x squared plus 2, okay. So du on the x will be equals to 2x. So that means that our du will be equals to 2x dx, okay. So when you check here, you see that this here from the same, this here is equals to this, okay, as in the expression here. So that means we can substitute that there and substitute this, okay, with u. You get it? So that means that we have our our integral of 2x on x squared plus 2 dx to be equals to the integral of u, to be equals to the integral of du on u, okay. So which will be equals to the ln u. Okay, and ln u, and u, you shouldn't forget that u equals, so we have ln u equals to x squared plus 1, so plus c, so that is c. So that is the result for the integration of the second term. Okay, which is, so now we look for, now get the integration for this. Okay, so let's scroll down. Okay, sorry. Sorry. So that will be the integral of 3x squared plus 2. Here, U substitution wouldn't work. Okay, the x, don't forget the x. So here, U substitution wouldn't work. So what will work will be to apply the trig substitution. So with the trig substitution, we should know that x will be equals to the square root of 2 tan theta. Okay, x will be equals to the square root of 2 tan theta. So if x equals the square root of 2 tan theta, so that means that squaring it, okay, squaring both sides will have 2 tan square theta. Okay, so this means that our integral will be 3, the integral of 3 all on 2 tan square theta plus 2, okay, dx. So we need to differentiate the x so that we express this in terms of d theta. Okay, in terms of d theta. So in terms of theta. Okay, so we have here we can have, so we have dx. Okay, d theta will be equals to square root of 2 sec square theta, secant theta. Okay, so that means our dx, okay, will be equals to square root 2 sec square theta d theta. Okay, so this means that this means that we have the integral of sorry, so we have 3. Okay, so the 3 comes to the back, so the 3 becomes the coefficient of the whole integral. So we have, and dx, our dx is square root of 2 sec square theta, so d theta on, so we can factorize this, the denominator. So we have 2 bracket open tan square theta plus 1. Okay, so but remember from trig identity, we have tan square theta plus 1 equals sec square theta. So this means that we have, this will be equals to 3, our integral to our integral of 3 on x square plus 1 dx will be equals to 3 integral of sec square theta. Okay, sorry, let me write it well. Okay, so we have square root 2. Okay, so we have, then it will be 3 root 2 on 2. Okay, so then integral of sec square theta on sec square theta d theta. Okay, so we have, so this implies that this will be 3 root 2 on 2 integral of 1 d theta. So when we integrate this, we get 3 root 2 on 2 theta plus c. Okay, so we have, but remember that x equals the square root 2 tan square root 2 tan theta. Okay, so we can make theta the subject here. So we have theta will be equals to tan inverse of x on square root 2. Okay, so we substitute into the equation. So we have the integral of 3 on x squared plus 1 dx will be equals to 3 root 2 on 2 the theta. So we have tan inverse of x on root 2. Okay, so we have, so tan, so we have this, okay, plus c. So writing everything together, so that means that our integral, okay, our final answer will be for the integral of 7x squared plus 5x plus 13 on x on x cubed plus x squared plus 2x plus 2 dx will be equals to, okay, let me write it here since it's long, will be equals to 5 ln absolute value of x plus 1, okay, then plus ln parentheses x squared plus 2 plus 3 root 2 3 root 2 3 root 2 on 2 tan inverse of x on 2 plus constant c. So here is our final answer. Thank you for watching. Drop your comments and do not forget to subscribe. Do not forget to like, subscribe, and turn on the notification button.